So today we're continuing right on with Module 3, Lesson 8. And your learning goal today is to be able to use a number line to help you add and subtract whole numbers and fractions. Okay, it shouldn't be too hard. We've worked with number lines way back in the very beginning of Module 3. Do you guys remember? Especially if you just did 3.1 on Zerd, you should remember. Okay, let's first talk about the problem of the day. We've learned a lot about different ways we can model math. Okay, so one way we can model this math problem, which you're going to write into your notebook, is 1 plus 1 3/4. Well, could I use a tape diagram to model that? I sure can. Go ahead and try that in your notebook. Here's how you would do it. I would draw that that's 1, and I'm adding 1 3/4 to it. And then if I find the total here, do you agree that that's tape diagram models the sum of 1 and 3/4? Yeah. Okay. Is that the only way we've learned how to model things? No, we've also learned to use a rectangular fraction model. Well, I could do that by drawing a rectangle and saying that that's 1. Do you guys agree? And then I want to add that to 1. And how would I draw 3/4? Well, I have to split it into 4 sections. And 1 and 3/4. Here's the first one. Here's the second one. And how many of these fourths would I need to color in? 3. 1, 2, 3. And I would, of course, label this over here as 3/4. Do you see how that's using a rectangular fraction model to model 1 plus 1 3/4? Yep. Okay, take a minute to make sure your notes are complete. Today, though, we're not going to think about tape diagrams. We're not really going to be focusing on rectangular fraction models. We are going to focus on modeling using number lines. So here's that same problem. 1 plus 1 3/4. A number line is just a line with numbers on it. There's arrows on both ends. I want you to notice that, because lines go on and on and on. They never end. At this point of the line, we have 0. When we start with addition problems, do we start with any value? No, so always start with 0. So I'm going to start from 0, and I'm going to start with 1. Do you see my first 1 there? So I'm going to add 1. When I get to 1, what number am I on the number line? 1. I'm going to add another 1. When I add another 1, what value am I at? 2, right? And now I'm going to add 3/4. 1/4, 2/4, and 3/4. Do you guys see how I split the distance between 2 and 3 into 4 equal sections? Here's 1 section, 2 sections, 3 sections, and 4 sections. And if I add 3/4, my answer is 2 3/4. Now in this example, we have a mixed number, don't we? We have 2 3/10, and then we have a whole number. Now when we have a mixed number, can we think of it as 2 parts, the whole number part and the fraction part? Yep. Do you agree that 2 3/10 is the same thing as 2 plus 3/10? Okay, so if I were to rewrite this problem, is that the same thing as 2 plus 3/10 plus 3? Yeah. Do you agree? Yeah. Now there's a property when we add numbers that says you can move those numbers around. Like, you know, it's like I commute from my house to my work by moving from my house to my work. So there's a property that says you can move things around, you can commute them around, and it doesn't change the value of the addition sentence. What's that property, everyone? Commutative. Commutative property. I love the commutative property because it lets me think about all the whole numbers first before I deal with those pesky fractions. So I can use the commutative property to rewrite this problem as 2 plus 3 plus 3/10. Again, the commutative property says if I commute those numbers around, move them around, it doesn't change the value of the number sentence. Do you agree? Yeah. Now, we have to set up our number line. So go ahead and draw a number line. Remember, number lines go on and on and on. They have arrows at both ends. They could go on till infinity and beyond, but we only have this much space, so we're going to draw it with arrows. And when I start my problem, do I have any value? No. What number do I start at?
0.
0. Okay. So I'm going to write my number line. 1, 2, 3, 4, 5, 6, 7, 8. Let's stop there. I'll go to 9. I have space. Okay. Now, if I start at 0, and I need to first travel how many numbers? 2, right? So I'm going to write at the top plus 2. Then I have to travel how many more?
3.
So here's 1, 2, 3. So this whole part here is plus 3. After I do plus 2, plus 3, what number am I at? What number am I at?
5.
5. Very good. Can we do that in our head too? 2 plus 3 is 5?
No.
Now I have to add 3/10. That means this whole number between 5 and 6, if I were to zoom in, I have to split it into how many equal sections?
10.
Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, and there's my 10th one. Good. How many of those sections are we going to move? 1/10, 2/10, 3/10. So when we're done, we'd be at this section right here. So over here, this is plus 3/10. Now if I zoom back out, you can't see it, but you know what's written there, right? Okay, now my ending point after is right here. So what's my whole number? 5. And how many fractions have I traveled? 3/10. Now I know what some of you are thinking. You're thinking, Miss O, I can do this in my head. I don't need a number line. To that I say, that's great, but if you can draw a number line, it proves that you can model it using a number line. So do you think today we have to draw number lines? Very good. Okay, so your answer to this problem, this addition problem, would then be 5 and 3/10. Here's how you use a number line to show subtraction. First, you'll need a number line. So go ahead and write down 1 minus 1/4. And here's my number line. If this is 0 and this is 1, what number am I starting at this problem? Should I start at 0 and move this way? No. Should I start at 0 and move this way? No. What number am I starting at? 1. So I'm going to start my movement here at 1. Now, I want to subtract. Does that mean the number is going to get bigger or smaller?
Smaller.
Is it moving to the right or to the left this time? To the left. Whenever I subtract, I go to the left. Whenever I add, I go to the right on the number line. Do you agree? So this is for subtraction, and this is for addition. If you're someone who's not quite clear on that, you might want to jot that down. Okay, if I want to go 1/4 of the way back, I need to divide this into fourths, because here's 1/4, here's 2/4, and here's 3/4. So in this case, I am starting at 1, and I want to go 1/4 of the way to the left. So I'm over here on the top, I'm going to write minus 1/4. Have you guys noticed each time that we move on the number line, we write a little plus or minus thing at the top? Yeah. Okay. When we move 1/4 of the way back towards the left, what am I at? 3/4. So therefore, 1 minus 1/4 is 3/4. This time, let's set up our number line. We have 0, 1 right here, 1 right here, and 2 right here. What number are we starting at? 2, because that's our first number. When we have addition and our first number is 2, do we start at 2 or do we start at 0? 0. Or we could start at 2 and add on, right? It's the same thing. Okay, now if we're subtracting, are we going to move to the right or to the left on the number line?
Left.
To the left. Whenever we subtract, we move to the left. Okay, we're going to move 3/5 of the way to the left. Now, how many equal sections do I have to split that up into then? 5. Okay, so 1, 2, 3, 4. Do you guys agree that 4 lines will split it into 5 equal sections?
Yes.
Okay, let's label these though. This is 1/5, 2/5, 3/5, 4/5, and 2 could be 1 and 5/5. Do you guys agree? Yeah. Okay. Now, how many of those fifths do we want to move to the left? 3. 1, 2, 3. Okay, and of course we're going to label this that we're subtracting 3/5. Okay. After we've done that, where are we on our number line?
1, 2, 3.
Yeah. Now, can I show you guys a very common mistake that 5th graders often make?
Sure.
They'll do what I just did. I'm going to circle it, and I'm going to say my answer is 2/5. I forgot the whole number part. Yeah, always check to see what your whole number part is, okay? And then you can confidently write that your answer is 1 and 2/5. In order to do 13 minus 7.5, do we have any mixed numbers? Yeah, we do, right? 7.5. So I can separate that out. That's the same thing as 13 minus 7 and then minus 1/2. For subtraction, can you commute it? Can I say 1/2 minus 13 minus 7? No. So with subtraction, you cannot commute the numbers, okay? Let's separate out the 13 minus 7 minus 12. Okay. Now, I'm going to start at 13, and I have to subtract how many?
7.
That means I'm going to move how many spaces to the left?
7.
1, 2, 3, 4, 5, 6, 7. Okay, so this part is minus 7. The red part is minus 7. Okay, I did 13 minus 7 so far. What do I have left? Minus 1/2. Okay, so that means between this whole number right here, I want to separate it into a half. Do you guys agree? Yep. And then right here, I'm going to move 1/2 back And when I'm here, what am I at? 5. My whole number part is 5. And then the fraction part is 1/2. So the answer is 5 1/2 what? Miles.